Hi, this is Dr. Nowley. In this video and the next series of videos, I'm going to be discussing concepts of chemical stoichiometry. So what I want to do in this particular video is just give you an overall broad introduction to what stoichiometry is, why we need it, and what concepts you need to master in order to be able to do stoichiometry problems. So the word stoichiometry itself means the studies of quantities of reactants and products in a chemical reaction. The idea is the following. If you mix these two reactants, the red one and the green one, for example, you're going to get a chemical reaction to happen, and at the end, you're going to have to figure out how much of the red reactant is left over. Apparently the green one is used up in this case. And we can also figure out how much of these products are being formed. And that's really the calculations that we'll be doing in chemical stoichiometry. So why is stoichiometry so important? Well, there are two main goals for people who study stoichiometry. One is very important because it allows us to relate microscopic quantities, things like atoms, ions, and molecules, to microscopic quantities, things that we can measure in terms of units of grams, liters, and other units of masses and volumes. The other thing that's very important is also stoichiometry has very much a practical application in chemistry. Okay? So on this slide, I want to give you a bit of a feel for why it's important to study stoichiometry. If you're a researcher in biology, for example, or neuroscience in this case, you can maybe one of the things you'll be studying is this dopamine molecule, which is a neurotransmitter. That means that it's a molecule that is being released from one neuron to another neuron. And by releasing that molecule, it allows this particular neuron, this nerve cell, to produce certain physiological responses. Let's say you study these responses and you understand that for a particular response to happen, the dopamine, there's a certain number of dopamine molecules that need to be released into this second nerve cell. Now, if you want to put that into practice in practical applications, for example, if you're a doctor and you have to inject dopamine to a patient, you're not going to be working in terms of number of particles or atoms or molecules, but you have to have masses or usually volumes in a syringe that you're going to use to inject to a patient. Now, stoichiometry allows us to translate that information from the atomic level information to the measured quantity, grams or milliliters type of information. Now, just on the side, dopamine is a very important molecule in neuroscience, actually, because it affects a lot of different physiological responses. For example, its role is important, for example, in learning, in movement, voluntary movement, in motivation, in understanding punishment, and understanding reward. So it's clearly a very important molecule that a lot of people are studying. And stoichiometry allows you to translate that information that you study on the molecular level to something that doctors or other people who apply these research into medicine can use. The second part of stoichiometry that I touched in the previous slide is this idea that it's very practical. The questions you can ask once you understand stoichiometry are listed here. Some of the questions that are really, really useful. For example, if you mix two reactants together, you get a reaction going. How much product are you going to get? Or if you want a certain amount of product, let's say 20 grams, how much of each reactant are you going to need to put into the flask? If you have two reactants and you get a certain amount of product, what's your yield? How much do you actually get in terms of percentage? Do you have any side reactions or other experimental issues with your reaction? You can figure this out by calculating that percent yield component. Do you have excess reactants? If so, how much can you recycle it, and so on. So I want to leave you here with the slide that tells you what's coming up. Basically, in order to be able to work through all the stoichiometry problems, you're going to need to understand all of these different concepts, and I'm going to deliver them, each of them in a video. So you need to understand the concept of atomic mass, molecular mass, and average mass, what is a mole, and then how we calculate molar masses and what is Avogadro's number. Then you need to understand the concept of percent composition, which is coupled with the idea of chemical formula determination. And then lastly, you need to know how to write a chemical equation, the concepts of limiting reactant and yield, and we're going to put all of these together in a couple of examples and then a lot of examples that we'll do in class.